another example optimization problem, and this one is a little bit harder, but it is still manageable. So the question reads, a window is being built and the bottom is a rectangle and the top is a semicircle. If we have 12 meters of material, what dimensions of the window will maximize the amount of light let in? So it's always good to draw the picture so we can get a visual of it. So in this case, the window looks like the following. It has a rectangle as a base, a semicircle on top. The radius of the semicircle is r. That means the length of the base would be 2r, since this is also r. So the length of the rectangle would be 2r. And the height we can label as h. So as of right now, the picture looks like that. So the next thing we want to do is we want to write the known and unknown equation. And remember, the known equation is the constraint equation, and the unknown equation is what we want to maximize in this case. So our known equation would be the constraints, and we're given that we have 12 meters of material, so that means that is the what do you call it, the perimeter of the window. So 12 meters, we have to set 12 meters equal to the perimeter of the figure. So the perimeter of the rectangle, remember we're only looking at this part of it, would be 2h plus 2r. So 12 equals 2h plus 2r plus, now we need to find what this is. If you remember, the circumference of the entire circle is 2 pi r. So the circumference of a semicircle will be 2 pi r divided by 2, which is just pi r. So the known equation is 12 equals 2h plus 2r plus pi r. So now our unknown equation is the equation we want to maximize in this case. So the unknown equation would be, since we want to maximize the amount of air let in, we want to maximize the area, so we need to find the area of this entire figure. So area equals the area of the rectangle, which is 2r times h. So 2hr plus the area of the semicircle. The area of a circle is pi r squared. So an area of a semicircle is pi r squared divided by 2. So plus pi r squared divided by 2. So here is our known and unknown equations, and at this step we want to maximize a, so we want to take the derivative of a and set it equal to 0. But notice how we have two variables in the right side of the equation, and so we can't take the derivative, so we want to make this whole right side in terms of one variable. Notice how there's only one h, so the best thing is to solve the known equation for h and substitute that into the unknown equation. So then we can then take the derivative and set that equal to 0. So right now we're solving the known equation for h. So we can get 2h equals, remember we want to subtract both of these terms. So 12 minus 2r minus pi over r. And now we want to divide by 2. So h equals, that's 6 minus, that's r minus pi over r over 2. So now we want to substitute this into the area equation, so we can get the area equation just in terms of r. So area equals 2 times 6 minus r minus pi r over 2 times r plus pi r squared over 2. So the area equals 12 minus 2r. 12 minus 2r minus, these two cancels out, so pi over r times r plus pi over r squared over 2. Right, and then we're going to bring in the r, so the area equals 12r minus 2r squared minus pi r squared plus pi r squared over 2. If you remember, pi r squared is equal to 2 pi r squared over 2, because the 2 cancels out. So then we can add these two terms together, so we get the area to be equal to 12r minus 2r squared. Negative 2 pi r squared over 2 plus pi r squared is negative pi r squared over 2, so minus pi r squared over 2. And that is the equation for our area. So now we want to take the derivative of this, and so we can set that equal to 0 and find our critical points to determine the maximum area needed. So let's take the derivative of this. So a prime equals, remember, take the derivative in respect to r, so 12r become 12 minus 2r squared will become minus 4r, and negative pi over 2r squared, remember the pi over 2 is a constant, so we bring down the 2, so it would be negative pi r. So now we want to set this equal to 0, so we could do 0 equals 12 minus 4r minus pi over r. If we subtract 12, we get negative 12 equals negative 4r. Negative 12 equals negative 4r minus pi over r. Divide by a negative 1, we get 12 equals 4r minus pi over r plus pi over r. Right, if we divide by a negative 1, and then we take out r from the right side of the equation, we get r times 4 plus pi. And if we divide by 4 plus pi, we get r equals 12 over 4 plus pi. So right now, after setting the derivative equal to 0, or the derivative of the area equal to 0, we got the radius is 12 over 4 plus pi. And remember, we can't just say that that is the dimension that will maximize the area, and we have to prove it. So let us use the number line test. So in the middle it goes 12 over 4 plus pi. And remember, we need to test points left and right of it. And in the derivative equation, and see the sign so we can determine whether it's maximum or minimum. So notice that pi is around 3, so this is like 12 over 7. This is close to 12 over 7, which is about like 1.4 or something like that. So if you pick a point left of that, or 0, and we plug it in here, notice that we get 0, 0, 0. Let's not pick 0, because then we'll get all zeros. So let's pick like 1. If you pick 1, we get 12 minus 2 minus pi over 2. That's a positive number, so we get upsloping line. And if you pick a number right of 12 over 4 plus pi, let's take like 15 for example, notice that these two terms will be much bigger than this 12r. So this will be negative, so we have a down sloping line. Notice that it makes a peak, so that is indeed a maximum. So the dimension r equals 12 over 4 plus pi would actually be the radius that would give us a maximum for the area. But remember, we need to find the height of it. So what we need to do is we need to plug this into this equation and solve for the height. So from the last step, we determined that r equals 12 over 4 plus pi, and at that point that the area for the figure would be the maximum. So it asks for all the dimensions, so we need to find the height. So what we need to do is we need to plug in this r into this equation and solve for the h. So we have 12 equals 2h plus 2 times 12 over 4 plus pi plus pi times 12 over 4 plus pi. So we get 12 equals 2h plus 2 times 12 over 4 plus pi is 24 over 4 plus pi, plus pi times 12 over 4 plus pi is 12 pi over 4 plus pi. Right, and we can combine these two terms, so we get 12 equals 2h plus, we're at the top, so we get 24 plus 12 pi over 4 plus pi. Then we can subtract this entire thing on from here, so we get 12 minus 24 plus 12 pi over 4 plus pi. And this equals again 2h. Then we divide everything by 2. So h equals, so divide 12 by 2 is 6, minus divide this entire thing by 2. Remember that if you're dividing by 2, this 24 will become 12, the 12 will become a 6. This 4 plus pi will stay as it is. So the height will be equal to 6 minus 12 plus 6 pi over 4 plus pi. So the dimensions of the window that would maximize its area would be r equals, so the radius equals 12 over 4 plus pi, and the height would be 6 minus 12 plus 6 pi over 4 plus pi. Thank you guys for watching, and please comment and subscribe below.